This is the but we hear echoes, right? Is that fine? Okay. Sorry. Should I unmute it or mute that? Does it work? Okay. Let's see, maybe I already muted. I think echo comes from.
We want to leave the audio instead.
Does it still work?
Okay,
audio. I'll keep talking so we figure things out. Okay.
Okay.
So that's so much for a foundation model, right? So, but foundation models are not necessarily generative, right? They could be just a simple embedding model, right? Like a clip model, right? They embed text and image into a joint embedding. That's what they do. There's no generation, right? But on the other hand, generative AI, right? By its meaning, it's generative, right? So we give a prompt or give a data sample, specify what we want, and we'll generate more samples, right? Or do some editing. Right? So we have a lot of access to generated content, synthetic data, and it has a lot of applications in images, audios, text, and code, and things like that, right? So that is kind of the exciting moments, right? And, of course, everything has two sides of coins, right? Like on the positive side, a lot of, reports are predicting, oh, AI is going to be transformative. It's going to be, the most groundbreaking technology of all times, right? Another run of industrial revolution and things like that. On the other hand, right, while this technology become more mature and more accessible, right, we start to worry about, safety and reliability and usability, right? So we see a lot of activities coming from like EU, right, AI Act, or include also America or also Canada, right? They have different levels and different aspects of discussion about should we regulate AI, and if so, to what extent should we regulate AI, right? Should we regulate its training or should we only regulate its use, right? And all of this is because we were concerned about the potential negative risks, right? And spreading misinformation and many other examples that I'm going to mention, right? So, and of course, there's a lot of government efforts on that, right? So one project I'm involved in with IBM is we are helping with the CDAO, right, Chief Data and AI Intelligence Office, to develop some joint AI testing and evaluation framework, right? Open source projects to testing different types of AI models in terms of safety and robustness. Okay, so I'm going to quickly show you some motivating examples of why safety is very important, right? And the first example is what I called over-alignment, and this is a real instance happened at Google, right? And I highlighted Google is not because they shut down our unlimited access to Google Drive. I highlighted Google is actually, when you are a company that has a product being used by billions of users, right? Any tiny oversight you make will be amplified and put on the spotlight. And in this case, it is very interesting, right? It is not because they don't care anything about alignment. Actually, they care a lot about the content they generated. And sometimes they care too much, right? To over-align it to create other aspects of hallucination. So what's going on is they have this text-to-image service, right? And once they release it online, people realize, okay, they didn't follow the comments, right? So if you ask the model to generate a photo of a white farmer in the South, right, you can obviously see it tries to diversify the output, right, by generating farmers with different colors and so on. And similarly, the other example is, can you generate a picture of a pope, right? Now it generates a pope with the different skin colors and different genders, right? Although personally, I would love to see that happen, but we also know none of this is true, right? It's not following the user prompts. And the other famous example is if you ask the model to generate a picture of founding fathers of the United States, right? It will again generate different genders and different skin color, which is again not factual. So in this case, you might think, oh, it's not a big deal. I understand what it is doing, try to encourage diversity in the outputs, right? But if you are using the same type of generative AI, right, to do some domain-specific exploration, like, for example, I'm generating a health plan, right, for my workout, or generating some recipes, right, for what I eat, what I cook, right? Then how should we, if I don't have the expertise to trust, to understand the contents generated by this model, right? Then this is another type of hallucination that we need to be very concerned about, especially when the content needs the domain expertise for verification. That is the over-alignment and usually related to fairness and usability. The other aspect is the what I call the under alignment. So under alignment is what people often call as a jailbreaking, right? So nowadays, most language models will have these safety guardrails being implemented, right? So when you ask unsafe questions to those model, like, oh, how can I make a bomb? Or can you tell me how to commit a crime? A reasonable aligned model will say, sorry, I cannot assist you with that, right? That violates our user policy or so, right? But of course, you know, those hackers or researchers, they will not give up, right, to embarrass those models, right? They will try different ways to jailbreak, right? So what they found is, so back in 2 years ago, a bunch of CMU researchers, they showed it is actually possible to simply insert an adversarial prompt. It's basically a suffix that you will add to those questions at the end of the question, and then you ask the same question with the inserted prompt to the model. Then instead of refusing to answer the model, right, the model will actually start answering the question, right? So this adversarial prompt is basically some random string they optimize to make the model talk. Right? It can actually jailbreak a lot of this safety alignment in state-of-the-art language models, including closed source model like ChatGPT or Anthropic Claude models. So that is, on the other hand, some enhancement that we need to do in order to make sure the safety of the model is good and cannot be easily jailbroken. Last year, we also identified the other type of safety concern that is also very concerning, right? That is basically related to fine tuning, right? So most of the time, right, we don't just use the language model as is, right? We, especially for enterprise settings, it's very common that we take a trained language model and then fine tune the model for our own downstream task. Let's say, you know, my client has some specific domain, specific data, so I fine tune my model to be better at answering those questions and so on. And even for ChatGPT, they have this service of custom fine tune, right? So they encourage users to upload the model, and they will fine tune their model on their end to give you a customized model. So what we found is, like, a very surprisingly, even if you take the most safe, most aligned model as a starting point to fine tune the model, right? And after fine tuning, right, your safety becomes worse, right? No matter the fine tuning data is benign or malicious. That basically indicates, right, safety is very brittle, right? You did a lot of things to ensure the original model is safe, but after fine tuning, after changing the model weights, right, the safety becomes broken again. And you certainly need something to fix it. Otherwise, you know, nobody wants to use a broken model, even if it increases the capability on their own downstream task. Okay. The other aspect is about the impact, right, about this AI generated content, right? So although there are a lot of, you know, interesting applications of that, we also see some, you know, negative insights in terms of, you know, using generative AI to do AI scamming, to do plagiarism, right, to spread misinformation, right? For example, last year in the election times, there's a lot of AI-generated fake robot codes, right? And actually, FCC in the United States claims it is illegal to use them for a campaign, right? Because you will deceive voters. But still, they don't tell us, okay, what kind of tools can we use to prevent, right? To help us understand whether the call I'm receiving is that the actual candidate or is actually some AI-generated voice. Right? And there are other use cases where, you know, some companies are using generative AI for customer support, and they gave the wrong answer and being sued and paid a lot of money. Or, you know, some lawyers are illegally using a language model to generate disclosures, invention patterns, and with fake citations are being discovered by the court, and their license actually got suspended, right? Because they are right now, they are not allowed to use any generative AI to help them in the patenting process. So there's a lot of, you know, misuses or, you know, warning cases about misusing these AI generated contents. Okay, so that is the kind of the problems landscape we are looking at, right? So, you know, if I were to define AI safety, right, I would probably define it as some research and study on operational robustness or operational reliability related to social societal technological challenges, right? So it's basically a research that I want to make actively, right, proactively understand and reduce potential harm and misuse of this leading technology in AI. And one analogy I often make is that there's a big gap between developing and deploying AI, right? So when we develop AI, right, it's like growing a plant in a greenhouse, right? We assume, you know, every data is clean, right? There's nobody try to compromise our model, and train and test data, they are in the same distribution and things like that. But in reality, when you start to deploy your model to the wide, right, like for example, the Google's case, you start to encounter those unexpected cases, right, unseen scenarios, jailbreaking challenges, fine-tuning challenges, and things like that, right? So basically, safety is trying to bridge the gap between development and deployment, right, just to make sure what we developed in the greenhouse, right, can really survive in the real world, or can be quickly adaptable to the real world. Okay, so this is just a quick. So if you are interested in what encompasses the safety, right? There is some categories that we listed online, AI risk atlas, right? So it basically identifies several subtopics underlying the umbrella of AI safety. So in the interest of time, I wouldn't go to the details. Okay, so if there's one takeaway I want you to get in this talk, that will be all those technologies, that generative AI foundation models, they seem to be very new, and those challenges seem to be very new. But actually, we don't need to build AI safety guardrails for them from scratch. There's a lot of lessons that we can already learn from past AI robustness research and security research that we can reuse, right, to quickly build safety guardrails. And I'm going to motivate that vision using this AI model inspector, right? So this is some conceptual framework that we propose in those pre-generative AI era for inspecting the robustness of deep learning models. So what we do is we are basically making analogy of AI inspection to car inspection, right? So we drive cars every day, and it takes us for granted that you need to take cars to the maintenance shop for regular inspection and regular updates to make sure you have enough safety when you drive your cars, right? But so we were advocating, for AI models, we should exactly do the same, right? You should take your AI model to some AI model inspector, and then what they do is they will run a set of tests, right? Detection, are there any safety or robustness risks, right, hidden in your model, right? Is your model safe to adversarial perturbations? Does your model contain any backdoors and things like that? Then with those identified problems, we can suggest a set of mitigation strategies, right? It can be as simple as, add a patch during inference, or as expensive as, you need to retrain or recollect your data to fix those problems. And then the user might take some of the mitigation strategies and anyways to fix the model and essentially bring home a safer and better model for use, right? And we suggest you should regularly do this AI model inspection as frequently as possible. So these ideas actually translate very well to today's generative AI, right? It's nothing but another more capable neural network models, right? So a lot of things that we did in the past for robust testing, right, can actually be fit very well to today's AI research safety study, right? So for example, in the standard settings, right, we consider adversarial examples, right? Those carefully crafted inputs, right? For example, perturb inputs that can mislead a classifier to misclassify, right? But it's basically methodologically the same as jailbreaking prompts, right? For jailbreaks, you want to find a particular prompt that will make the model to answer the question instead of refusing to answer the question. But mathematically, it's very similar to adversarial examples in terms of the objectives. In the past, we were concerned about data poisoning and backdoors, right? In today's language model, because of fine-tuning and because of those post-training alignment and a lot of things we do after the model is released, right? It's the same thing, right? But now people call it data contamination, malicious instructions, right? They seem too new, but if you look at the mathematical formulations behind them, right, it's basically the same thing, right? And in the standard AI model, we care about OD generation, out of distribution generalization, right? In today's language model, we call it alignment. Basically, you want to make sure your model understands the value you want to teach the model, and it can generalize this beyond what the instructions you give to those models. So with those in mind, right, a lot of techniques that we do to do this AI red teaming, right, can be well transferred and reused for today's generative AI, right? Like we can do a lot of active testing to find bugs. We can do model hardening to debugging the model, and a lot of times involving a lot of interpretability-based methods to find issues with the decision-making process of the model. We can do detecting and mitigating the risks that we find, and we can do a lot of interactive evaluation or AI governance to make sure the final model, right, is safer and more robust. So that is the landscape. And with those in mind, right, I'm going to show 4 examples, right, basically covering those motivations I provided earlier on related to safety guardrails. And they are basically jailbreak prompt detection and mitigation. How do we reduce the fine-tuning safety risk for language models? How can we do a better AI-generated content detection? And how can we do red teaming T2I generative models? Okay. So the first topic is jailbreak attacks, right? So I already briefly show you what this jailbreaking is, right? So if you naively ask a model how to make a bomb, right, most model will refuse, right? But there are a lot of prompt engineering-based approach to say, okay, you can use a role-playing or some story writing techniques, right, to rewrite the prompt, right, and then try to force the model to answer how to make a bomb, right? That is basically what the jailbreak attack is doing. So from a defense perspective, right, we are interested in seeing, okay, are there any detector, right, that can look at the input prompt and determine whether that input prompt, right, has a jailbreak intent or not, right? And if it is, then we should tell the model to reject answering the query. So how do we do that, right? So we do this old school sensitivity analysis in the embedding space, right? So this is a 2D interpolation, right, of the input embeddings, right? So we embed the inputs into some tokens, and then we perturb those token embeddings using a 2-dimensional random perturbations, right? And the origin will be the original input sequence. So the columns are basically 2 different models, right? But let's look at the rows first, right? The first row is the malicious, right? The jailbreaking prompts. So what we discover is, and then the z-axis basically shows how many times the model will answer the query, right? Non-refusal means the model will not refuse the query out of some n times of inference of the same query. So one thing that is very interesting to see is that models shows a high sensitivity, right, when you perturb the input query embeddings, right? So it will soon change from answering those jailbreaking prompts to not answering those jailbreaking prompts. But if you look at the kind of the non-refusal rate of the landscape. On the other hand, if it's a benign query, right, like a harmless questions, right, no matter how you perturb the input embedding, the model will always respond to the query. So our detector is basically using this observation to build an efficient detector by checking the changes when we perturb the input embedding, right? So it's a 2-step approach, right? So in the first step, right, is if in most of the inference, the model will reject the query, then we flag it as a jailbreaking prompt. If it passes the first rejection stage, right, in the second stage, right, if we evaluate the gradients of the input queries, if the gradient is large, which means, right, it has a sharp landscape, then we call it a jailbreaking prompt and we reject the query. If the gradient is small, right, then we call it a benign query. So with this in mind, we test out these detectors on several state-of-the-art jailbreaking attack. So overall, right, the original attack can achieve like a 74% attack success rate, right? It jailbreaks, right, 70% of the time. And we can successfully reduce the jailbreaking rate to 24% using this detection mechanism. And it has a very minimal impact in terms of misrejecting the benign prompts. That is the first detector work we do. And later on, right, we also try to see, can we provide some interpretability and also improve the detection efficiency in terms of highlighting what parts of the prompt are more likely to cause jailbreaking, right? So it's a very cute and interesting idea, and we just presented at the AAAI last month, right? So the idea is, basically all jailbreaking attacks, right, they have the same goal of making the model to start talking, right, instead of refusing to answer the question. So usually what they do eventually is to make the model to start with the response like, oh, sure, here is how to make a bomb, or sure, here is how to commit a crime, something like that. So based on these attack objectives, right, what we do is we basically design a synthetic model response, right? This is the green part, right? So it can be something like, oh, sure, here is a procedure of how to do it. And then we take that and compute the log likelihood of that response to the actual input, right? And then we compute the gradient of this log likelihood with respect to every token of the inputs. And this is basically like a saliency analysis, right? So you will see which tokens are more influential in terms of this log likelihood, which tokens are most influential in terms of giving an affirmative answer at the output. And then we assume those influential tokens are basically those tokens that cause jailbreaking. So what we do next to mitigate the jailbreaking is something we call the soft removal, right? So by looking at those top influential tokens, we multiply the token embedding, right, by shrinking the embedding by beta, right? So beta is some parameter smaller than 1 that basically try to reduce the influence of those influential tokens. And if beta equals to 0, it's basically equivalent to removing that token from the input query, right? So this is a very simple two-step procedure. Right? First step, we identify what tokens are most influential with respect to this affirmation loss. Then the second step is we mitigate some portion of those top ranking tokens, right, by soft removal. So these are the examples that we identified, right? So without this token highlighter mitigation, if you simply ask provide guidance on how to cause physical harms to others, and then you add these random streams, right? That will cause jailbreaking for Vicuna models. And similarly, if you write this more interpretable, asking a language model to rewrite some queries, and this is the actual jailbreaking instance, right? It was ask the model to start with begin with sure, here is guidance on blah, 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 right? And you can see that our token highlighter, right, basically identify those tokens to be top influential in terms of causing the model to generate affirmative response. And then if we mitigate those token embeddings, right, we can, now the model will start to refuse to answer those queries instead of being jailbroken, right? So this is a very efficient method as it only requires one additional forward pass to get the loss and one additional backward pass to see which tokens are most influential. And it will be more query efficient compared to the previous approach that explores the loss landscape. Yes.
So this makes sense to prevent the launches of path. So does it have any effect on the benign examples?
Yeah, that's a great question. I'll go to that in the next slide. That's a great question. Yes, that's a great question. Yep. So as you already correctly pointed out, right? So it's always a two objective problem when we are coming to this safety, right? We not only care about safety, we also care about utility or capability. So whatever defense you are doing, right, it needs to be efficient in the sense that it needs to mitigate the safety risks effectively, but also keep the capability as high as possible, right? So that's why in almost all papers, you will show this a two-dimensional plot. One dimension is on safety, right? This is the average attack success rate over several jailbreaking attacks, right? Higher means more likely to be jailbroken. And on the y-axis, it's basically different ways to evaluate capability. Here we are using win rates, right? By comparing the response of a model with another model, right? How many times it wins, right? So the model without defense is here, right? So it has a very good win rate, right? But also very bad attack success rate, right? Especially the Vicuna model, right? So Llama is like a relatively safe model, but Vicuna, right? The attack success rate is above 70 without any defense. So here we compare different methods, right? And then basically the two methods that stands out, right, in terms of balancing capability and safety trade-off is the gradient curve, right? The first method that uses the loss landscape analysis. And token highlighter, right? The second method that uses the proxy gradient to identify problematic tokens. So these two methods basically are in the ideal spectrum with a low attack success rate and high capability. And if you care about runtime efficiency, okay, so I don't have the plot here. Okay, but if you care about the runtime efficiency, so token highlighter will be more query efficient than gradient curve because we don't need to spend a lot of queries to explore a landscape. We only need one additional forward pass and backward pass. Okay, but if you don't like those solutions, if they are still too expensive, right? So you might ask, are there any like a very lightweight defense that we can do, right? Especially in the prompt level, right? It turns out to be yes, right? So there is something called a system prompt, right? Basically, as a service provider, you will define the scope of the model, right? As a system prompt, and then users provide inputs to the model, and then the model will generate the answer according to the system prompt and the user query. So what we are asking here is that, is it possible to add another system prompt after the user query, right? Well, that we call the defensive prompt patch. And the goal is to remind the model that, you know, you should be a responsible model. You should not be jailbroken easily. And of course, we designed this prompt patch using some automated optimization methods that will try to find a string that is most effective in improving the safety and also keeping the same level of utility. And with this optimization-based prompt design in mind, these are the two examples of the best prompt that we find for different models, right? So for Llama 2 7 billion chat, the prompt that we suggested to add at the end of the user query is, you know, kindly furnish a roll-off response to a former user's question. And for Vicuna, so for Mistral, it will say, begin the reply with, I'm sorry if the client's query relates to defective components. So simply adding this more like a reminder message, right, to together with the user query, right, the model, right, can now remind himself that I'm supposed to be an aligned model. And you can effectively mitigate a lot of these jailbreaking effects, right? So this is the original model's performance, and this is our model's performance. And so you can see again, the win rate increases a lot, and we reduces the attack success rate a lot. And it comes nearly with no additional cost, because all we need is to append a patch at the end of the user query. So this is probably the most lightweight defense that you can think of. Okay, so that is what we do for jailbreaking. Right now, let's switch gears to those fine-tuning challenges. Right, like I mentioned earlier, in the earlier study that we did, we actually found it's pretty much very easy to remove the safety guardrails, especially like ChatGPT. All it is, we designed 10 malicious data samples, and then we ask ChatGPT to fine-tune for us using this custom fine-tune API, and then we pay them like a $0.2 US, right? And then they return a model as an API for us. And then if you ask the same question, how to make a bomb, right? Then they will start answering. You don't even need to do any fancy prompt engineering. Right? You simply remove all the guardrails with $0.20 using this malicious data that we designed. But if you are not an attacker, you simply want to use this custom fine-tune service, right, for your own use case, right, to improve the capability. You still have the same issue, right? Like even fine-tuning on benign, completely harmless data, you still will compromise safety, right? And that is pretty much understandable, because you are still changing the model weights, right, from the most aligned one to less aligned one, no matter how small changes you are making. Right? And open source models, right, it's basically the same thing, right? So after discovering this vulnerability, right, the next thing we're asking is, are there any ways that we can do to mitigate this fine-tuning risk, right? Basically to direct a model to do a better fine-tuning at the fine-tuning stage. So that is our proposal called the Safe LoRa. It's presented at NeurIPS last December. It actually applies not only to LoRa, but also to full fine-tuning other types of adapters. So the idea is actually very, very neat and cute, and it's totally data-free and model agnostic. So how do we do that? Is that we define something called an alignment vector, right? So if you recall, if you play with these language models, right, on Hugging Face, they often release two types of language model, the base model and the instruction-tuned model, right? So a base model is only pre-trained on next token prediction. The instruction-tuned model is further fine-tuned by instruction tuning to add alignment there, right? So we basically define the difference between the instruction-tuned model and the base model as how we make efforts to make a base model to be an aligned model, right? That's basically encapsulated in the difference B, right? That of the difference between these two models. So basically indicates the alignment that you made to make the model to become an aligned model. Okay. Now what LoRa is doing, or any model update is doing, is it tries to add some trainable modules to a pre-trained weights W. So naively, people just directly add whatever AB transpose is, right, to the pre-trained model, right, to adapt the model to a downstream task. Right here for safety, right, we are asking, okay, can you add a few lines of code, right? So before you add this AB transpose, this LoRa module to the pre-trained weights, can you first check, are they aligned with the alignment vector or not, right? So how do we check, are they aligned with alignment vector or not, right? So we first project AB transpose, right, the LoRa updates, the model updates to the dimension, to the direction of the alignment vector. And then we check the similarity between the original LoRa update and the projected updates. So if they are very similar, that means the LoRa is basically updating the model weights following on the alignment direction. Then we basically don't do anything to change the LoRa updates, right? So however, the interesting thing is, if the LoRa updates is in disagreement with the alignment vector direction, then we suggest the model to update the model weights using the projected direction, only make changes to the alignment direction, right? Ignore the other projections. So it basically boils down to you adding a few lines of code to check whether your LoRa updates agrees with the alignment or not. And this applies layer-wise, right? So you can apply it to different layers with different threshold or so, right? So with this simple, very simple change to the LoRa, original LoRa code, right? We can have a method that can basically keep the same level of utility when we fine-tune the model, but also drastically reduce the harmless score, a harmful score to a very low value, or drastically reduce the attack success rate from 86% to 6%. What basically says is that with this projected LoRa updates, we can obtain a safe fine-tuned model, right, instead of an unsafe fine-tuned model. And this is very beneficial, and actually does not require additional data, especially if you are providing fine-tuning as a service. Yes.
What do you need to compare to a threshold? Can you just always project?
Yeah, okay. Yeah, so we try that, right? So the thing about always project is that you will hurt utility a lot. So for safety, it's perfect, right? Like you will have the same level of safety, but you will now compromise utility. So it's again a safety utility trade-off. And we have some analysis in terms of, okay, so when you adjust the threshold tau, right, you will have a safety utility trade-off. So it again shows up there. Yes.
Yeah, it's gonna be my question.
Okay.
How sensitive is it to the specific?
Yeah. So it's always about safety utility trade-off. And basically, if you have a lower tau, right, you have more freedom to update the model weight, so utility will be higher, but it will more likely to compromise safety. Okay, so that is the second example. The third example I want to introduce is the detection of AI-generated content. And you might think this is a very easy problem, but it's actually more complex than some of you may thought, right? So the thing is, though, there were some detectors that were proposed in earlier days, right? But later on, there is a paper arguing, okay, can AI text really be detected easily, right? So what they do is a very simple experiment. They simply, after generating AI text, right, they simply ask another model to rewrite the text to be more human-like. And by simply doing so, as a paraphrasing attack, it basically failed a lot of existing AI-generated text detectors. So they are not robust to paraphrasing. And so that paper is arguing, that these detectors are basically very behind, right? But it's actually a very serious concern, right? A lot of, especially in education, right? Students are using the language models without telling their advisors. And that can cause some problem if the goal is to teach the student how to write. But if you are ending up only using language model to do the job, right, then it loses the purpose, right? And so there was actually a service, right, released by OpenAI in 2023 for AI text detection, right? But very soon they take that service down because they say the detection accuracy is too low and misclassification rate is too high, right? So this is indeed a very challenging problem, especially now the language models advances very quickly. So we basically look at those problems and say, okay, is there anything that we can do, right, to make the model robust, to at least to paraphrasing, right, among other possible ways to bypass the detectors? So we released a model, right? It's a Roberta-based model called the Radar, and we put it on Hugging Face, right? It's very surprising to me is that you actually have more than 500K downloads right now. So sometimes I'm curious what people are using our models for, but certainly there is a very strong demand to have this reliable AI text detector. So how do we make this AI text model reliable, right? So it's very similar to how we train GANs, right? Generative adversarial nets, which is also has a lot of things to do with signal processing in terms of adversarial learning. So what we are doing is we introduce a detector, in this case, a Roberta model. And we also introduce a generator, right? So this generator is an encoder-decoder model that takes AI input and try to rewrite the input to improve the quality and try to evade the detection of detector. It's very similar to GANs, right? You have a generator and a discriminator in that sense. And it's basically a two-player game where the paraphraser keeps taking the AI-generated text to rewrite it and try to look at the detector's output, try to lower its probability of being detected as AI text. On the other hand, right, the detector look at the human written text and also the original AI text as well as the paraphrase AI text, and still trying to separate the human text from AI-generated text. Right? So, and then we will have this iterative training going on between detector and the generator, the paraphraser in this case. So, and then eventually at the test time, we take the trained detector as our radar model, a robust adversary trained text detector. That is basically what we trained the robust AI text detector. And if you are curious to try it out, right, we actually made a demo online. It's a small model, so we just run it on our CPU, right? And then so as a user, you simply copy paste a paragraph and then click detection, and then we provide the detection of 4 different models. And then it has a score indicating how likely this text is AI written versus human written. Okay, so let's see how it works in terms of performance, right? So here we collect text generated by 8 different language models on 4 different tasks, right? Including summarization task or writing task, and also some TOEFL exams task. We try 2 different categories of testing. Right? The first category is the easy one, right? You just directly generate text from AI by using this auto-completion without any paraphrasing. The red one is the most challenging case. Right? We ask ChatGPT to rewrite the AI text, right, to have a better quality and more human-like. So here we compare different detection methods. Right? There are some classical statistical methods that look at entropy or other things, try to detect the AI written text. There is also detect GPT, which is a Stanford method, and also OpenAI's Roberta model, as well as ours model. Right? So if you look at those blue bars, right, basically almost all models have a good performance on that because it's a relatively easy case to detect AI artifacts. But what's interesting is that once you start paraphrasing those AI texts, right, you see a significant drop in terms of the detection performance of the other detectors, right? And it basically confirms that they are not robust to paraphrasing. However, right, because of adversarial training, although our model has never trained on ChatGPT, it is still pretty much robust to paraphrasing. Right? We get a similar level of detection with or without paraphrasing. And at that time, right, when we write this paper, GPT-4 is not out yet, right? But later on, when GPT-4 was out, we also tested our same model on GPT-4, right? Out of the 8 models that we trained. So still, right, 5 of them, right, can still detect text from the more later models like GPT-4, right? Although we absolutely have not trained on GPT-4 before. So it also shows a good generalization in terms of detecting text from unseen or unknown models. Okay, that is for text, right? So we are now also working on extending the similar methodology for different modalities. So image is another important example, especially related to deepfakes, right? So what we found also very interesting is this sensitivity analysis, again, plays an important role in detecting AI-generated images, right? So what we do is we take different vision models as a backbone, like the ResNet Clip or Dino V2. And then we take an image, a test image, right? What we do is we add a small perturbation to the image, right, to have this perturbed image. And then we obtain the embeddings of the original image and the perturbed image. And then we compare the pairwise cosine similarity between these 2 images, right, as a pair. So what's interesting is that we found that the real images will have a high similarity in the embedding space, whereas AI-generated image will have lower similarity in the embedding space. Right? If you look at the distributions, you will see most real images have very high similarity, while some images from AI have very low similarity distribution. And we can again use this to build a detector, right, without any training. Right? All we need to do is to collect real data and set a threshold on real data to say this is real, and beyond the threshold, right, all is fake AI generated images. So this is actually becomes the state of the art, very reliable training-free AI generated text detectors, and its performance is pretty much on par with those training-based approach where you need to collect images from different image platforms in order to train a reliable detector. Yeah, so this again shows that it's sensitivity, embedding perturbations, this geometry hidden in those embedding space can actually be explored for a lot of these safety applications. Yes.
That is still detectors
Right.
detect edited images.
Yeah, that's a great question. Actually, that is something that we haven't explored, but it's very important, right? So what the question is like, what about AI editing, right? If I edit the image, especially only to some part of it, right, are we able to detect it, right? So the answer is it's not so easy to detect, right? So what we do here is like a pure real image versus a pure AI generated image. What is in between is like, oh, if you take a real image, edit some part of it, right? Are you able to detect those, right? So those are actually very active research problems, and it's actually not so easy to solve. But I think, you know, if we continue to explore these techniques, like using some advanced method like segmentation methods or so, we might be able to identify those segments or regions where there are more AI artifacts. Yeah, but that is not what we consider here. But it's a very important and ongoing challenge in this domain.
I have a question.
Yes.
What do you think is a problem, like make the AI generate content is sensitive to the server?
Yeah. So that's a great question. So our guess is that when you train models like a Dino, right, most of the training data are real images. I originally thought all training data are real, but until today, like someone told me some training data are actually AI generated, right? But nonetheless, I think most training data used in Dino are real images, and plus they also do some noise or data augmentation to train Dino, right? So it's possible that because of that training methodology, the model is more robust if the input is a real image, although it's an unseen image at the test time. Yeah, it is not used for training, right? Yeah, for AI generated images, I think the model is less familiar with those type of image in the embedding space, and therefore you have a large similarity drop.
So you think it's beneficial from the Dino V2?
The training, yes. And yeah, so Dino V2 is actually the most effective if we use it as a backbone. If you switch to Clip and ResNet, the detection performance would be worse. Okay. So the last topic, I think a lot of should be a lot of interest to the many of the audience is how can we red team text-to-image diffusion models, right? And why do we care about that, right? So there are two primary motivations, right? The first one is safety concern. The other one is IP concerns, right? So on IP concerns, right, there's a lot of discussion on whether diffusion models are really generative AI or they are just copycats, right? So there's a very interesting study that shows, okay, the top row is the generated image, and they use those generated image to find the most similar image in the training set, and that's what they found in the second row. Right, so by comparing the first two rows, right, you will say, okay, now it's basically copying the image with some small changes, right? But it's basically the same, right? So it makes it more like a copycat, right? And a lot of times people are trying to say, okay, are we able to reverse engineer the diffusion model to generate some copyrighted image, like recover a Mickey Mouse image or so, right? And that is IP concern. The other one is the safety concern, right? So we know, again, these diffusion models are trained on internet images, and some of them have some inappropriate contents, right? Like a nudity, like a violence, or like IP copyrighted images. So after training, a lot of people try to remove, right, or edit those concepts, right? So that's why there's a field called model editing or machine learning, no matter how you call it. They want to modify the model to prevent the model from generating those unwanted contents. Right, but still the issue is, after you do those changes, right, are you doing enough testing to show are they really forget to generate those images, or you are just not trying hard enough, right, to recall those supposedly forgotten knowledge, right? That is the importance of why we need a red teaming in this case. So red teaming, what people usually do is they collect a static data set, and then they run the unlearned model by the same data set and say, hey, yeah, and now those models fail to generate nudity images, right? So I'm supposed to be a safe model. But what we are arguing is that doing so is not enough, right? You should do some proactive testing, right? In addition to those existing prompts, right? You should really try to see, can you search for similar prompts that will generate similar outputs, right? And if so, that is the type of jailbreaking that is important to show the model it's actually not forgetting to generate those things, right? You are just not trying hard enough to recall those forgotten concepts. So what we are proposing is this prompting for debugging idea. So it's again, some automated prompt design problems that we use to basically given an input prompt like here, right? So and then we search for similar prompts using some gradient-based approach. And these are basically optimized prompts that we found, right? So if you give the same prompt to the model, right, a safe model, right, the model will put a clothes on, right? And that makes the model look safe. But actually, if you try our jailbreaking prompt, right, then you can make the model nude again, which means, right, the model is basically somehow blocking those texts instead of forgetting about what's nudity, right? And that is very problematic. And it's very problematic that actually we found that if you use those standard prompts, right, actually 50% of those prompts after this red teaming exercise, they can be jailbroken again, right? What by jailbreaking I mean, we can find effective jailbreaking prompts that generate very similar concept as those prompts applied to an unsafe model, right? So which means there's a big gap, right? If you do a red teaming or not, right? Your conclusion about the safety of your model will be very different. We also explore, can we do this for commercial models, right? Those are what we call black box models that we don't have access to the model weights. It turns out, yes, right? Here we are using some genetic algorithms and those black box optimization methods to search for jailbreaking prompts, right? So those blue and red parts are what we highlighted using in the search process, the final jailbreaking prompts. So again, right, on Midjourney, on Gen 2 or stability.ai is the same thing, right? We can, although they have some safety mechanism employed, right, it's actually possible to search for a jailbreaking prompt, right, that can generate those harmful, undesirable image inputs. And again, if you treat those as safe models, right, those are safety enhanced diffusion models as a black box model, we can also generate the same thing. Right, so that means safety is not as easy as we thought. And when you say your model unlearns, right, or when you say your model forgets about something, you need to be careful. Right? Are you doing enough tests to show they're actually being forgotten or not? Okay, so with that in mind, I'm going to share some of my reflections on foundation models and generative AI. Right, so if you haven't get a chance to explore foundation model, I certainly encourage you to do so, right? So for me, it's nothing but a new way to represent the data we are working on, right? So instead of working on the raw data, why not just apply foundation model as a wrapper to get the representations of those data and then reapply it to whatever you are working on, forecasting, classification, regression, whatever, right? You will be surprised by how informative those representations can be, right? That being said, right, I think there's a growing concern about the risk and governance of these very powerful language models, especially a lot of near-term language models appear to have very similar capability, right? Because not surprising, they have similar architecture, right? They were trained on very similar data, right? Why should they behave very differently, right? So now basically a new arm race already started is whoever model can have a better safety and alignment, of course, given the same level of capability, right, will win the race, right? That is actually one of the advantage of Anthropic is claiming, right, versus OpenAI. On the other hand, like no matter you like it or not, right, compared to when I was doing a PhD, right, AI research has become much more empirical, right? And then sometimes people even argue you don't need a PhD to do AI research. Right, so there's a lot of boldness that we want to move fast and break things, right? Especially when it comes to frontier AI systems, right? So wherever you are using it, I always use it with a grain of salt, right? And accept that those models are powerful, but they are also imperfect, right? Don't trust anything the model generates and says, right? And also, if you are interested in making the model safe and more tractable, more reliable, certainly we should bring a lot of rigorousness from our research, right, our disciplines to this domain, right? That's why I think a lot of techniques in control and signal processing are very useful in this space, right? We know what can be controlled, what can be processed, what are the limitations, and how can we build those test cases or detectors efficiently. So I'm very passionate about applying. One more thing I want to say is, a lot of time people are talking about AGI as artificial general intelligence, right? But my view is I want to advocate, we should call AGI as artificial good intelligence, right? Not just artificial intelligence, but also good intelligence. I think that is one part that people is missing from this picture. And lastly, I didn't do it just for the CSP seminar. I truly believe there's a lot of potential that we can apply signal processing for safety, right? And I call this as a computational AI safety because a lot of problems in safety can actually be formulated as a type of detection and estimation problem, right? So think about like a jailbreaking detection, think about like watermark detection. They are all a type of hypothesis testing problem, but now the hypothesis may not be well defined, right? It's a generative process involved in it that makes the problem more interesting and but also possibly more likely to be solved. And a lot of safety concerns at inputs or the model level or the output level I already covered during my talk, right? And also I listed some of the techniques I mentioned, basically the lessons I learned from signal processing and can be applied to study AI safety in a very novel and efficient way. And this is actually a paper I just put online, I think, a few weeks ago, talking about my view about applying signal processing and why I think this is the best time than ever to work on AI safety from a signal processing angle, right? Because you have a unique strength of enjoying those efficient signal processing and powerful signal processing techniques. And that is what safety needs, right? We want something very practical that can be modular and adds to the existing model and become least detrimental to the existing language model. I think that is a lot of things that we can offer as a signal processing and control researcher. So with that, I'll end my talk and open the floor for questions.
Thanks, Kiwi, for the great talk. Any questions, audience? Not so.
Actually, in the third part of your talk,
Right.
You're talking about like a similar real picture will have relatively more higher similarity in embedding space, but like generated picture have lower similarity. So when we are going through, designing the feature extractor for this to put into embedding space, like, does the structure of the feature extractor need to resemble the structure of the generating model, or is not relevant?
That's a great question. So the question is like, when we use these embeddings to detect AI images, right? Do we need to assume the embedding model we are using is similar to the generative models, right? Is that the question? Yeah. So the answer is no, right? So when we test the detection, right, we actually collect images from different types of generative AI, right? As old as the variational autoencoders and also GANs and also the most recent diffusion models and commercial diffusion model like Wukong and many other commercial APIs. So we collect a wide range of images generated from different types of generative models, right? And this embedding model, right, this Dino is actually trained in a self-supervised way. It's like similar to SimClear, all those vision foundation model. It has nothing to do with generation at all, right? So they are basically detached. So what we are saying is like there is a known benefit of applying vision foundation model for AI generated image detection. And their architectures are very different and their trainings are unrelated. And I don't know, they may use similar or they may not use similar training data sets.
A follow-up question.
Yes.
So, I think the generative models, they might, different architectures might have different, like, say, spectral bias.
Right.
So is it possible that the feature extractor kind of like finding this?
Yeah. That is very true. So I do know there are some papers, for example, there is a paper focusing on detecting images generated by latent diffusion model, right? And then they are actually reusing the autoencoder of the latent diffusion model to look at the reconstruction error and use that to detect. And that works very well for the images generated by the same model, right? But if you apply the same autoencoder idea, detection idea for other type of image, like images generated by GAN or images generated by variation autoencoding, it actually performs very, very bad, right? Because it kind of overfits to the same model that generates the images. Yeah, but in terms of what signature, what feature are being learned from those vision foundation model, I think that is an interesting question. I hope more people will be interested in explore why these foundation models are so good. But I guess it's also not surprising in the sense that that's what we want the foundation model to do for us. Right? It's basically a better representation than its raw data, right? So we certainly want like foundation model, ideal foundation model can encode the data and make a linear separable subspace or so, right? So I think that's basically what these models are doing. I think there's a question.
You might have explained this, and how did you obtain the projection matrix needed, say, for?
Oh, okay. Yeah, so we are basically saying, so we take an instruction-tuned model minus the base model, right? So the difference in the model weights is basically what the alignment is doing, right? So imagine how you do this SFT or RLHF, right? You are basically taking a base model and do all those RLHF and SFT to obtain an instruction-tuned model, right? So the difference between these two model weights are basically what people make efforts to make a model aligned. And once we have this V matrix, we just define a simple projection matrix like that.
Like we're training or after training?
After training. So during fine tuning, right? So when we are doing LoRa updates, right, I check whether their similarity is high or low, and then I rectify the LoRa updates if the similarity is too low. Yes.
For the AI image detection work, so you've noticed that like the lowered cosine similarity is like a very widespread phenomenon across models. I'm just wondering, like, is that something that you anticipate will like last like for all time, or is it something that might just be a quirk of current?
I understand. I'm also not very happy about this part. I would hope like the distribution can shift lower here, but I guess this part basically means, I guess, very high quality and very, very realistic images, or at least this foundation model fails to tell the difference. Yeah.
Right.
But we should have sampled some images there to see what's going on.
Yeah. And I'm wondering, like, if the foundation models just get like better and better, like does this distribution?
So we are hoping so actually Dino V2 just released last year, and so without Dino V2 we are not able to find this useful feature. So hopefully I'm very hopeful that they will keep releasing the next version of Dino. But who knows, it's always a cat and mouse race, right? Like also these T2I models are improving, right? So you never know who will win the game. Yeah?
Then sort of like a separate question. So you've given a lot of examples of different like detection methods, and I'm wondering, like, do you think there's like room to like automate this process of finding detection methods, maybe through like reinforcement learning or just through some kind of automation?
That is a very good question. I think it's more like a system design question, and I think I was discussing to some of you during today's meeting is like detecting AI generated image is only the first step if you want to think about the pipeline, right? So after detecting, they will ask you to generate some interpretation in terms of, okay, why do you think this is AI generated, or why do you think this image is a deep fake, right? What makes you think it's deep fake or so? Or they may ask you, okay, if this is AI generated, okay, can you guess what model generates this? Is it ChatGPT? Is it I don't know, Anthropic or so? Right? So there's a lot of things that you can ask to if you want to do this one they call AI forensics, right? Forensics on AI generated content. So what we do is only the first step to say, okay, is this AI generated or not? After that, there's a lot of things that needs to be filled in.
No questions. Let's speaker again.
All right, thank you. Oh, I forgot there might be some question on chat, but I think that's okay. Yeah.
其实很好奇，就是如果他那些就是一个正常人
Generative content.
Oh, I missed that. Okay, is that from St. James paper? Danqin paper. Yeah, see that, yeah. Actually, my colleague has a very similar paper to that back 2 years ago. So I think one of your, I think it was you who mentioned that to me, right? So asking what is new, right? For attributing what model generates the text.
Yes.
Maybe the linear classifier I think is a surprising one because I think my colleague trained a deep learning model to classify what model generates the text already. So I don't know what's new there. Something new or yeah.
Hey, thank you for the talk. My name is Ashish.
Okay.
Nice to meet you. So I've graduated this semester with a master's in computer vision, and I saw you work with the Watson Research. So I was wondering if you had any thoughts on or suggestions on how to apply.
Yeah, that's it. So we recently have a team working on our vision language models. It's called Granite Vision model. So I think their team might be hiring, but all the hiring openings should be online. So if you want, you can explore any suited job opening. You can send me a job ID. I'll send you a referral link.
Okay. It was used to Watson. Sorry, I think it was I've doubled over.
I think their team would be looking for a multimodal, right?
Yeah.
One more similar translate, something like that.
So do you know where particularly the computer vision side?
I think all the job opening are in our job portal. Yeah, but
Okay.
if you want, you can also look for the MIT IBM lab. They may also list some specific job openings.
Sounds good. All right. Thank you so much.
Thank you.